On December 5, 1952, London stepped into a wall of wet, yellow-brown air that would hang over the city for about 5 days, leave early death counts near 4,000, and later force historians and doctors to raise the toll to roughly 12,000. The smell was bitter: coal smoke, damp brick, cold soot on the tongue. Street lamps turned into blurred orange stains. Breath felt heavy before people understood why. This was the start of the Great Smog of London, December 1952. But the story does not begin with death. It begins with a trap. A windless anticyclone settled over the city. Above the streets, warmer air formed a lid. Below it, colder air could not rise. That is a temperature inversion, the atmosphere doing the opposite of what people expected. Smoke should have lifted and thinned out. It did not. It stayed where people lived. And London was ready for that trap in the worst possible way. In the post-war years, homes burned low-grade, nutty slack coal. Power stations added more. New diesel buses added more still. Cleaner coal was being exported, so the dirtiest fuel stayed by the fireplaces, chimneys, and streets of the capital. By the time the fog thickened, the city had already loaded the air with material waiting to be sealed in. That explains why the air turned dark, but not why it became deadly enough to keep killing after the fog itself began to thin. If you want the rest of this story, stay with me and leave a like. That trapped air did more than dim the lamps and stain the fog. It changed what people were breathing, minute by minute, at street level, inside buses, in bedrooms, in stairwells that smelled of damp wool and soot. At first glance, this should have behaved like ordinary smoke in ordinary winter weather. Coal smoke rises, thins, drifts, loses strength. That is the expected pattern. But under the temperature inversion, the city's exhaust did not clear. It sat inside cold fog droplets, close to mouths and noses, close to the skin, close to the lungs. And inside those droplets, something far more dangerous began to happen. The key was chemistry, not just dirt. London's air held sulfur dioxide from domestic fires and the wider fuel load, and it also held nitrogen dioxide. In the wet fog, nitrogen dioxide oxidized the sulfur dioxide. As the water later evaporated, what remained were acidic sulfate particles, a sulfuric acid aerosol, fine enough to go deep into the lungs. In the throat, in the eyes, deep. That difference matters. A person can feel smoke and step away from it. These particles do not announce themselves so clearly. They travel inward. They settle where the body is weakest. And once they are there, the damage does not end when the air outside starts to look a little clearer. Which is why the most frightening part of this event was not what London could see, but what it could not. And that invisible part is what made the city so slow to understand its own emergency. People could see the brown fog on the windows, taste the soot, feel the damp on their coat sleeves, but they could not see those fine particles settling deep where a cough could no longer clear them. So London kept moving, badly. Buses crept forward, if they moved at all. Homes stayed heated by the same fires that were feeding the air outside. Power stations did not pause. Diesel engines did not vanish. The streets, the rooms, the stairwells, all of it remained inside the same low ceiling of poisoned weather. The smog was inside daily life, woven into it, not just hanging over the city. This is the part that matters. The danger did not come from one dramatic source. Not one chimney, not one district, not 1 hour of bad weather. It came from accumulation. Low-grade fuel in thousands of homes. More emissions from industry. More from transport. Then the fog, then the chemistry, then the lungs. cause folding into cause. And that chain helps explain one thing: why so many people began to struggle for breath. It does not explain the next thing. If this had only been an ugly week of dirty air, the damage should have faded when the air cleared. But the death count did not stop when the streets began to reappear. In some ways, that was when the full scale first started to emerge. That delayed wave is what turned a filthy weather event into a public disaster. The streets could begin to show themselves again. The lamps could sharpen. The wet grit could settle on windowsills and coat collars. And still, the damage kept moving inside people's chests. This is where the early numbers matter. At first, the count gathered around roughly 4,000 deaths. Even that was staggering for a city that had not been struck by flood, fire, or war in those days. Most of those deaths were respiratory and cardiac. That detail is not secondary. It points straight back to the air itself, to what had been trapped, transformed, and inhaled over those 5 days. And yet, even that figure explained only part of the event. It captured the immediate shock, not the full reach. A person weakened by those acidic particles might not die in the middle of the brown fog. They might worsen after it thinned, when the city was already trying to return to routine. The mechanism had already been set in motion. So the first public picture was too small, just incomplete. What looked like 1 week of severe smoke exposure was beginning to reveal itself as something larger, measured not only in what happened from 5 to 9 December 1952, but in what followed after. And when later analysis widened that frame, London's disaster more than doubled in size. That widening gap between the first count and the later one is one of the most disturbing parts of the whole event. It means the smog was larger than the city understood while it was happening, and even larger than it admitted when it was over. Early reports settled near 4,000 deaths. That number sounded terrible, but contained. A disaster, yes, yet still something a government or a newspaper could imagine filing under extreme weather and post-war hardship. Then, later analysis looked not only at the days of the brown fog itself, but at the excess deaths that followed. The result was far worse, roughly 12,000. That revision matters because it changes the shape of the story. This was not one sharp spike and then recovery. It was a rolling aftermath. People with damaged lungs do not all fail at the same hour. People under strain from breathing do not all collapse on the same street. Some worsen at home, in bed, with the smell of cold soot still caught in blankets and curtains. Some survive the worst visibility, then decline afterward. So the event split into 2 realities. One was visible: buses slowed, lamps blurred, faces wrapped in scarves. The other was statistical, delayed, and harder to deny once the numbers were laid side by side. And that creates the next problem. If the true scale was so much worse than the first public picture, why did the system not change at once? That hesitation tells you something important about this event. A city can know it has suffered, can smell the soot in its curtains and feel the tightness in its chest, and still resist the idea that its ordinary habits were the cause. Post-war London depended on what it had. Domestic fires burned the same low-grade fuel that had already filled the air with coal smoke. Power stations still mattered. Diesel buses still mattered. Cleaner coal was still being sent elsewhere. None of that changed in a day, because none of it had been built in a day. The smog exposed a system, not a single mistake. And systems are hard to accuse while people are still living inside them. If a home is cold, a fire feels like safety. If transport is running, smoke from the street can look like the price of modern life. If the worst danger is made of particles too fine to see, then the city has an excuse ready at hand. Perhaps this was only a bad spell of weather, an ugly week, an unfortunate mix of fog and winter. That explanation can carry a government for a while. It can carry newspapers for a while. It can even carry the public for a while. But it cannot hold forever once the deaths keep accumulating and the pattern becomes impossible to ignore. Because by that point, the question was no longer whether the air had been foul. The question was whether Britain would admit that the air itself had become a political problem. That was the real turning point. Once the death toll stopped looking like a tragic side effect of winter and started looking like the result of choices, the event moved out of the weather column and into the realm of policy. The air over London had done what arguments alone often cannot do. It made an invisible system visible. Home heating, fuel quality, transport, power generation, urban planning. All of it had been breathing through the same streets. For years, that arrangement had seemed normal. In December 1952, normality turned against the people living inside it. And this is where the disaster becomes harder to dismiss. A storm passes. A cold snap passes. Even a dense fog usually lifts and leaves the city more or less where it was before. This did not. It exposed that the capital was built around combustion at the level of daily life. Not an occasional industrial accident, but routine fires in routine homes feeding a routine sky until that sky stopped dispersing what it was given. So the question sharpened. If the same habits could produce the same result under the wrong atmospheric conditions, then what exactly had to change? Warnings, better forecasts, and telling people to stay indoors when the smell turned bitter were not enough. Something structural had to move. The old arrangement had to be broken. But before Britain reached that answer, it first had to accept a more humiliating one. That the city had nearly asphyxiated itself with its own idea of ordinary life. That admission did not come easily, because once the crisis became political, it stopped being only about fog and lungs. It became about fuel, housing, money, and the uncomfortable fact that the same fires warming kitchens and sitting rooms had also helped poison the air outside. Britain after the war was not built for quick purity. Homes relied on what was available, and what was available was often the dirtiest grade. Cleaner coal was still being exported. So the burden stayed local, in grates, chimneys, and street-level exhaust. That is what made this disaster so difficult to solve. The cause was everywhere ordinary life touched a flame. And yet that very ordinariness sharpened the case for change. If the city had been struck by one factory accident, the answer might have been simple: close the source. But this was spread across domestic heating, power generation, and transport. 1,000 familiar acts had added up to one lethal atmosphere. The lesson was brutal. When danger is distributed, responsibility is distributed too. So any real response would have to reach into daily routine, beyond emergency warnings and public statements after the dead were counted. The structure of urban air itself had to be redesigned, because under the wrong sky, the same pattern could happen again. That is the point where London's smog stops being only a historical event and starts becoming a blueprint for law. And the next move would change how Britain was allowed to burn fuel at home. That legal blueprint was not a gesture of sympathy. It was an admission that the old fuel order had failed in public, at scale, and in full view of the state. By 1956, Britain answered with the Clean Air Act. The name sounds calm, almost modest. The reality behind it was not. The law pushed the country into smokeless zones and off raw coal in domestic heating. In other words, it aimed straight at the daily source that had helped load London's air before the inversion sealed it down over the streets. This is what makes the aftermath so important. The reform did not try to control fog. It did not try to command the wind. It changed what people were burning. That is the core lesson. Weather was the trigger, yes, but the real vulnerability was the material already waiting in the air, ready to be trapped, mixed, and inhaled. And there is something almost brutal in that logic. A city can survive unusual weather if its background systems are resilient enough. It is much less safe when ordinary life is constantly feeding the atmosphere with the ingredients of a crisis. The Great Smog of London, December 1952, forced that truth into law. But law is one thing, and memory is another. Governments can rewrite fuel policy. They cannot guarantee that later generations will remember why it had to be rewritten. And that forgetfulness opens the door to the most dangerous part of this story. That loss of memory matters more than it seems, because this event is easy to flatten into an old black and white image. Fog, chimneys, coughing, then reform. But that version is too neat. What happened in December 1952 was not just dirty weather from another era. It was a full chain reaction between atmosphere, fuel, transport, housing, and lung chemistry. Once that chain is forgotten, the disaster starts to look accidental. It was not. The anticyclone mattered. The temperature inversion mattered. The exported cleaner coal mattered. The low-grade fuel burned at home mattered. Power stations mattered. Diesel buses mattered. Each piece on its own could be explained away. Together, they formed a city-sized machine for concentrating harm at breathing height. And that is why this story reaches beyond London. Not because every modern city burns the same fuel in the same way, but because the structure of the danger is familiar. Urban life still depends on systems people barely notice until those systems align in the wrong order. Air is the perfect hiding place for that kind of risk. It is everywhere, so it disappears from attention, right up to the moment it does not. The law changed the fuel pattern. It did not repeal the basic physics. It did not erase the possibility that a city could once again trap what it emits near the ground. And when governments model that possibility now, they are not studying a Victorian curiosity. They are studying a warning. That warning is really about pattern. Once you strip away the old chimneys, the post-war fuel shortage, and the specific look of London in 1952, what remains is a structure that any modern city should recognize. First, emissions build up in ordinary life. Then, weather stops those emissions from dispersing. Then, chemistry changes what people think they are breathing. Then, the body pays the bill later, not always at once, and not always where the danger first looked worst. That is why this event still matters. The Great Smog of London, December 1952, was not only a tragedy of coal smoke. It was a demonstration of how a city can quietly manufacture a health disaster out of routine conditions. And that is the part history tends to soften. People remember the dark air, the muffled lamps, the taste of soot. They remember the image. They do not always remember the sequence: fuel, atmosphere, reaction, lungs, delayed death count, law. But the sequence is the real story, because sequences repeat more easily than images do. The Clean Air Act of 1956 changed one version of that chain by pushing Britain towards smokeless zones and away from raw coal at home. It broke a link. It did not abolish the possibility that other links, under other conditions, could form again. So the final question is no longer what happened in London. It is what kind of city notices a chain like that before the death count teaches it again. That warning becomes sharper the moment you bring it into the present. Not because modern cities are identical to London in 1952. They are not. But because the same broad sequence can still exist in different clothes. A city emits, weather stalls, pollutants stay low. Chemistry does the rest. People notice the smell, the haze, the irritation, and still may not understand the exact mechanism until the medical pattern appears afterward. That is the chilling lesson carried forward from those 5 days in December. The deadliest part was not only what people saw in the streets, it was the gap between exposure and comprehension. And this is why the old event still sits inside planning, forecasting, and public health thinking. The Clean Air Act broke one historical chain by pushing Britain into smokeless zones and off raw coal at home. But laws aimed at one fuel do not end the deeper vulnerability. They only reduce one pathway. The atmosphere can still trap what a city produces. Human lungs have not changed. Delayed harm has not changed. So when officials study air episodes now, they are not only asking, how dirty is the air? They are asking a harder question. What happens if ordinary emissions meet stagnant weather in the wrong chemical mix? That is a very different level of fear, because it means danger can grow out of systems people trust every day. And once a government starts asking that question seriously, it usually leaves a paper trail. And that paper trail is where the story becomes modern in a way that should make anyone uneasy. Once a disaster like this has been measured, counted, and tied to a chain of causes, it does not stay in memory alone. It moves into risk planning. That matters because the old event already proved something brutal. A city does not need flames in the street to suffer mass harm. It only needs emissions low enough, weather still enough, and chemistry efficient enough. In 1952, the mix came from domestic fuel, power generation, diesel traffic, fog, and that stalled air over London. The specific ingredients may change from era to era, but the logic does not. Air can become hostile without looking dramatic at first. It can arrive as nuisance before it reveals itself as public danger. This is why the later history of the smog is not just about law or even about memory. It is about whether institutions learned to think in chains instead of isolated problems. Not fog, smoke, cold weather, or hospital pressure, but one linked system where each ordinary part feeds the next. That is the only way the event makes full sense. And once you see it that way, the Great Smog of London, December 1952, stops being a sealed chapter. It becomes a template, a case study in how modern life can generate its own invisible emergency and recognize it too late. Which leaves one final question hanging over everything that came after. Did the country truly learn the right lesson, or only the most convenient one? The most convenient lesson would have been simple. Old London was dirty, then Britain cleaned it up. But that is not the real ending of this story. The real ending is narrower, colder, and harder to forget. From 5 to 9 December 1952, a windless anticyclone held a temperature inversion over the city and kept the air close to the ground. Homes burning low-grade fuel, power stations, and diesel buses loaded that air. Chemistry turned it worse. Early Britain counted about 4,000 dead. Later analysis pushed the excess deaths to roughly 12,000. Then, the state changed the fuel order with the Clean Air Act of 1956 and the spread of smokeless zones. That sequence is the answer, a chain. And chains are dangerous because each link can look ordinary by itself. A fireplace is ordinary. Fog is ordinary. A still winter sky is ordinary. Even a cough in cold weather can seem ordinary, until all of them lock together. That is why this event still stands. Not as an old photograph of blurred lamps and soot-black walls, but as a room with the windows shut, a fire burning for warmth, and harm already inside the house before anyone calls it a disaster. After the fog lifted, the brick stayed damp, the curtains held the smell, and the city kept breathing. The air had cleared. The lesson had not.